Hello, it's What the Doodle here. I'm a senior engineer with 20 years in the industry, completely burnt out, and now I just do content and doodle. I came across this article written by John Viega. I do hope I've pronounced his name correctly. Apologies if that isn't correct. And initially, I was going to write out a response. However, I'm lazy and I've decided to do this as a YouTube slash audio response. Now, John is incredibly credentialed, so a lot of the things that he presents here are factual, and there are a lot of good points to agree with. However, as with a lot of things, us individuals, we can have a certain perspective, and oftentimes the same thing, there can be multiple perspectives to it. And this is obviously an incredibly detailed article, and John has, hats off to him. He must have spent a considerable amount of time and effort in order to put this together. So there's no criticism on John himself, but it's just to provide a different perspective that he may not have considered. And obviously, because the article is very long, I haven't been able to read the entire article. I have skim read bits of it, and the main thing that I've really focused on is the TLDR version that John has written himself. So this is a summation, or his summation, of the article. And there's a few things that I just happened to notice, which I believe may be kind of the fundamental reason as to why he believes the things that he does in this particular article. Okay, so let's jump straight into it. In his first point, he says the security problem is indeed more significant than many people seem to believe, and many people would absolutely be much better served abandoning C/C++ right away for new projects, and not just from a security perspective. Now, this is a very curious and interesting point that's laid out in his summation, because it would appear to be at odds with the actual conclusion that John has come about in his title. Rust isn't just a hangover cure. However, of course, John further then caveats that with a big massive but exclamation mark, meaning whilst he does believe that to be true, these are his caveats and the reasons and rationale why perhaps that rationale, or perhaps that statement, doesn't hold. So in his second summation point, he says, it's far more costly and risky to get rid of all of our C applications are already using than many people might think. I'm not sure if I can read past that correctly. Let me just reread that. It's far more costly and risky to get rid of all the C our applications are already using than many people might think. Creating replacements to some key pieces of software will take a decade or more to be effective as a replacement. So I don't think I can disagree there. Of course, rewriting existing software is a long endeavor. It's not something that will happen overnight. So I'm not sure. I mean, there isn't a disagreement there. And I don't think anybody is under any illusion that software can be replaced overnight. So I'm not sure what kind of point is being made here. It's almost, I think, obvious that rewriting existing software takes a long time. So yeah, and of course, given that there's a lot of old software, it's going to take a lot of time. So this is already, I don't think anybody would push back against that. Now, the second or the final part of this point of this summation, he says, with no clear overall benefit. Well, I don't agree here, because we know there are lots of advantages and benefits, and it isn't just about security, because obviously John is a security expert, I would like to say, and so obviously he's looking at everything through the lens of security. But Rust as a language isn't just all about security. That's one aspect of the advantages. Of course, when you rewrite software and migrate it into another language, into another stack, and you modernize it, there are inherent benefits when you do a rewrite. Oftentimes you'll expose things and bugs and design flaws that were never there. Sometimes like with everything in hindsight, everything is a lot understood a lot easier. So to say that there are no clear benefits, I'm sorry, I can't buy that, because we can objectively show many advantages for doing that rewrite. And if it wasn't the case, then many individuals who are the authors of those said original languages, they themselves are picking up, because they've had enough of dealing with unsafe language. Not just unsafe languages, but there are numerous benefits in terms of tooling, in terms of better language for abstraction, in order to be able to encode and present that problem, in terms of when you get rid of a lot of technical debt that may have built up over decades. Of course, there is a long list of things that could be said, but to make such a bold statement with no clear overall benefit, unfortunately, this is hand wavy. There's where that has to be shown with evidence to say that there is no clear benefit. Even if an individual provides, even if one benefit is provided, then this would completely negate this statement. So on to the next point, which is point number 3. There is a lot of hidden complexity just when we consider security that complicates the equation to the point where saying Rust is safer than C might be true, but actually it isn't a total slam dunk. Well, again, there are some truths here. Yes, safety isn't just, there's multiple facets. There are trade-offs. I believe that's what he's hinting at. There are trade-offs, and it isn't so black and white. And again, nobody would disagree. Yes, so again, I'm not sure. So does that mean because there are trade-offs that we should not consider improvements when there are improvements? I mean, I'm not sure what the rationale here doesn't quite add up to me anyway. Point number 4, the economics of something as simple as choice of programming languages are actually very intricate. Okay, that's interesting. Not only is security not the only non-functional consideration. No matter what you do, there will always be memory unsafe code somewhere. Okay, as long as the underlying architectures themselves are unsafe. So, I mean, again, I don't understand the point of this. So, are you saying because there is unsafety, we should get rid of we shouldn't bother with unsafe languages at all? This doesn't make sense. The logic doesn't follow. So that's to say, because there is a small deficit, or let's say there's a dent in your car, does that mean you have to throw away your entire car? Is that the kind of logic that's being espoused here? Because it doesn't follow. Sure, yeah, there are going to be safety issues in every application or language that you use, but I think the issue here is that if you think about it as a surface area, surely the idea would be to minimize that. If you were given 2 options, option A, which has a very large surface area in terms of unsafety, and option B, which has a much smaller area, why would you say, well, because we didn't get rid of that, because option B still has a safety area, we're not going to use it? Clearly that doesn't make sense. It makes no logical, rational sense. Given 2 options, we always pick the lesser evil. The lesser evil, yes, doesn't mean that the evil's gone. The evil's still there, but it is of a lesser evil. So this kind of thinking and rationale again doesn't tie up. It doesn't make sense. So on to his 5th and final point: system languages are overused. C versus Rust is a false choice because compiled languages like Go are often much better and all-rounded economically. Go has a particular decent enough performance that is sufficient for the vast majority of use cases, will be safe, and has good access to low-level system APIs. Well, I mean, first of all, there is some confusion here. He talks about system languages, and then he jumps on to talk about Go, which is has a runtime, it's memory safe, and has a garbage collector. But then so does .NET, so does Java. These and Python and the other ones. I mean, Java is compiled, and it's compiled to a virtual machine, as is .NET. The C# is compiled to a virtual machine. The virtual machine is a runtime, which is memory safe. So, but nobody would consider, for example, Java to be a systems language, nor would they consider .NET to be a system language. The fact that something, just because a language is compiled, does not necessarily mean that it is a system language. A system language is one I would consider a system language is one that doesn't have a garbage collector in it, and it is one where you can write a garbage collector in and doesn't require a big fat runtime or a virtual machine. Those are what I would classify as a system language. So therefore, Go is not a system language. This doesn't make sense to bring Go here unless he's saying, well, why are you considering these two together? Why not just jump to a memory safe language? Well, that doesn't make sense either, because these two are in the same category, whereas Go, .NET and Java are in a completely different category. So why this doesn't make sense. You're conflating two different genres, if you like, or two different topics, or two different categories, or two different classes, if you like. And confusing with the fact that because it's compiled, well, that isn't the compilation of it is not an attribute for it to be a system. Is not an attribute for it to be a system language. It can be, but it isn't. So again, I don't understand these points that he's sort of making. So there is one other aspect I want to quickly pick up on what John had said, and this bit sort of stuck out. Obviously, as I mentioned, I haven't read in detail the entire article, and he talks about how the risks have changed, and he says here, and this is very telling. He says, "Here I will firmly acknowledge other languages are inherently safer." So he's already admitting, by his own statement, by his own admission, that other languages are safer than C and all the languages that have predated them. But then he's essentially trying to question it, and then his question goes, how much safer, especially if we have the right controls and are vigilant. See, this right here, I think, is the complete misunderstanding of this whole, I would say probably the whole, if you like, the premise which the whole thing is built upon is I think the misunderstanding right here. Because if you scroll further up, there is another aspect where he talks about essentially about C developers. He talks about I'm trying to find it, sorry. Here it is. C programmers have tended not to use them. So he talks about being vigilant, having tools and all kind of things in order to be able to find these vulnerabilities and make sure applications are secure, or the languages can produce secure code. But by his very own admission, C programmers tend not to use them. I wonder why. It has to be because all of this, having these extra tools and quote unquote being vigilant, it's completely wrong way of thinking and approaching this problem. It's basically shifting the burden over to the developer and over to the human, and humans are fallible, and that's entirely the problem that's trying to be solved here. It's the whole point of the safer languages, and is the idea that we move it away and push all of those things not inside toolings, and we don't depend on external tools, or we don't put it on, and we certainly absolutely do not put it on over to humans and developers to burden that. What we do wherever we can is we move that to the language. If we move it to the language, then the compiler can take that burden on. If we let the compiler take that burden on, then we don't have to rely on humans. We don't have to rely on vigilancy. We don't have to rely on discipline. We don't have to rely on so many things that can fail. And the argument here is, it's probably one of the dumbest arguments. If you really stop and think about it, what he's essentially saying, we can paraphrase. We can sort of give an analogy. It's like saying, why should we design seatbelts? Seatbelts are not needed if we are careful drivers. That's what this article boils down to.